to get the formula for the distance covered by a body in the nth second. This end has shown here is what now? A particular position. Look at the question we have back there. When it starts from rest and moves with uniform acceleration of 6 meters per second square, what distance does it cover in the third position? Third position, that is what now? A particular what now? Time, third second. Are you with me? So this is the formula that we are going to use to solve this kind of question. This kind of question is what now? Is in fact, it is normal. You see it in JAM, you see it in what now? In Japan, even in WAEC. This kind of question is a special case under what now? Motion of the body in a straight line, which we call what now? Kinematics. Are you with me? Now look at this. Look at this. Before I explain that, look at this. Suppose I have a shape like this. Are you with me? I have time t naught. I have time t1. I have time t2, time t3, and time t4. I have distance s naught. At t naught, we have distance s naught. We have distance s1, distance s2, distance s3, and distance what now? S4. If we are being asked to find distance covered by a body, suppose this is the body A, okay? What is that covered by this body? At the fourth second, it is distance covered in the fourth second minus distance covered in what now? Third second. Are you with me? Distance covered by this body A in the fourth second is distance covered in the fourth second minus distance covered in the third second. Meaning distance covered in the last 1 second of its motion. Okay, you can say it like that too. So it implies our distance covered by this body in the fourth second is equal to distance covered in the what now? In the fourth second minus distance covered in the what now? In the third what now? Second. So we have to find distance covered by a body in the nth second. We use Sn is equal to what? Sn minus, this one is 4. How do you get 3? This one is not n. N is 4. How do you get 3? That's what now? 4 minus 1. We have what? Sn minus 1 now. And so on. So this is the formula for the distance covered by a body in the nth second of its motion. So let us get the unique formula for that. Let's go. Now, we recall that the distance covered by a body in the time t is given as ut plus half at squared. You see, remember this? Now, if this is our n now, our t becomes n. T becomes n. So we have Sn is equals to, anywhere we see t, it will change to what now? N. So we have un plus half an squared. This is the formula for distance covered by the body in the n second, not n2, n second. So we need to know 2. Distance covered by what now? N minus 1 second. So what is the formula for distance covered by the n minus 1 second? This will now be, anywhere we see t to change to what now? N minus 1. So this will become u open bracket n minus 1 plus half a, then we have n minus 1 all squared. So let us open this bracket. It will now be what? U times n, I have un, u times minus 1 minus 2, then plus half a. What is n minus 1 squared? Look at this. I have n minus 1, n minus 1, n minus 1. This is n minus 1 squared. So let us open this bracket. Now n times n squared, n times minus 1 plus n, minus 1 times n plus n, minus 1 times minus 1 plus 1. So this one becomes what now? N squared minus 2n plus 1. So it means this one here is n squared minus 2n plus 1. Let us open it all. So now we are having un minus 2 plus half a times n squared, half a n squared, half a times minus 2, half a times minus 2, what happen? Minus 2n, rather, what happen? This 2, we cancel out this one now, this 2, now we have what? A times minus n. So this one become minus a n. The last one, half a times plus 1. You see how what? Plus what now? Plus half what? Plus half a. But the formula is distance covered in the n second is equals to distance covered in the n second minus distance covered in the n minus 1 second. So it means our distance we're looking for, don't forget, is equals to what? Distance in the what? N minus distance in the what now? N minus what? N minus 1. Distance is the n. Where is it? It is un plus half an squared. Okay? The minus, this is in bracket. What's the distance in n minus 1 second? This is what now? Un, you have minus, open bracket, un minus u plus half an squared, minus an plus half a plus half what? Half a. So this is the formula for that. Let's now finally open the bracket. Finally open the bracket. Now we are having un plus half an squared minus times un minus un minus times minus u plus u minus times plus half an squared become minus half an squared minus times minus an plus an minus times plus half a plus what? Half a. And everything cancels out. Un minus un out. Half an squared minus half an squared. So I cancel this one, cancel out this. This one cancel out what? Cancel out this. Now having u plus an minus half a. So it will now be u plus an minus half a. Un plus an minus half a. The next thing comes between an and half a is common. I can factor a out. Now we having u plus, if I bring my a out, I'll let it what now? N minus what now? Minus half. So we can use this formula for a distance covered by a body in the nth what now? Second. Let us further simplify it. I see how what u plus a bracket. What's the SCM here? This is what is 2. This is what number 1. 1 into 2. 2 times n, 2n minus 2 into 1. 1 times 1. You have 1. And plus 2n minus 1 over 2 is the same as saying 2n minus 1 times 1 over 2. Okay? 2n minus 1 over 2 is the same as saying 2n minus 1 times what? 1 over 2. So this, I can bring this 1 over 2 out. Are you with me? So let me bring that 1 over 2 out. So if I bring this 1 over 2 out, we are having final result equals to u plus 1 over 2a into bracket 2n minus what now? Minus 1. So this is the formula. This is our rate what from distance covered by the body in the nth second of the solution. Distance covered by the body in the nth second of the solution. Where is what now? The initial velocity. A is the acceleration and n is what now? The time given here. Fifth. Put 5 here. You can't explain this kind of question in what? In JAM, like I told you in Jupiter and in WAEC. It is special type of what now? Distance. Special type of distance. So you can just pause the video, write the formula. This is what we need. This is what we need. So let me just clean it. Let me clean it and we can solve the question. Let me clean it and we can solve the question. Let me clean it and we can solve the question. We clean everything and let's see. Now, whenever you have to find distance covered in the n second, you don't need to let your mind be troubled. Okay, I just showed you how they got the formula. What we need is the last word of the last formula. And what is the formula? The formula is what now? Distance covered in what? In the n second is equals to what now? U plus half a open bracket 2n minus 1. That's all. This is the formula you need. Okay? Distance covered in what now? In the n second. N second position. Let's answer that question. Question 1. The body starts from rest and moves with a uniform what now? Acceleration of 6 meters per second square. Whenever a body starts from rest, the value of its initial velocity equals to what now? Is 0. So the first one, question 1, u equals to what now? 0. because the body starting from what? Rest. Then our A is equals to what now? 6 meters per second what? Square. What distance does it cover in the third? This is that third second, end second. This one. So let's so our n is what? Our n is what? Is 3 third second. So let us apply it into this one. So let's cover it what now? In third second equals to 0 plus r times what our A? Our A is 6. Open bracket. We have 2 times our n is what now? Is 3. 3, then minus what? Minus 1. So now equals to what? 0 plus r times 6. 2 times 3 is 6. 6 minus 1 is what now? Is 5. So I'm having times 6 is what now? Times 5. 2 here, 1, 2 here, 3. So we have what? Is 0 plus what now? 3 times 5. We have 15. That is as covered in the third second will be equals to 15 what? 15. This is what? Jam question 1992 question. You can see it. 1992 jam question. So the correct answer is 15 meters. So let's solve the second one. Okay, so distance covered in the n second. This is the formula. Please, are you with me? This is a special case under what now? Motion of the body in a straight line. Kinematics. Special formula. So a car starts from rest, question 2. A car starts from rest. U equals to 0 to 2. You see? Moves with a uniform acceleration of 10 meters per second. Our A equals to what? 10 meters per second what? Square. For 10 seconds, our T is not given here. T is what now? 10 seconds. I said, what distance? The distance is covered in the last 1 second of the motion is, look at this. Distance in the last 1 second. I have, look at this. I have T1, T2, T3, T4 to T9, and what now? And T10. So because the time is what? 10 seconds. Are you with me? So here I'm having S9, S1 now, S10. E is what now? S4, S3, S2, S1, blah, 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 blah. So this is covered in the last 1 second. Last 1 second of his motion will be, this is covered between what now? S10 and what? S9. That is covered in the last 1 second. Last 1 second. Between 10 and what now? And 9. So that would be distance in what? In the 10 is equals to what? Distance is what now? 10 minus distance is what now? 9. This will give us what? Distance the body will cover in the last what now? 1 second of his motion. So let us apply the formula. So what will be our n? What will be our n? So what's our n? If you look at this word now, what I explained here, our n goes to what now? 10. I'm going to solve this question in 2 ways so I get the concept. This has covered in the last 1 second. This is where the last 1 second is. Between what now? 9 and what now? This is last 1 second. Last 1 second. Okay? That will be satisfied in what? In the 10 minus satisfied in what now? In the 9. So this is distance in the what? Last 1 second. Last 1 second. Last 1 second. So let us go. Our S10, let's use this formula. Our S last 1 second will be equals to what? U plus R A, okay, 2N plus what now? Minus 1. Our N is 10, like I said. Our U is what? 0, so we have 0 here plus R times. Our A is what? Is 10, 2. Open bracket. 2 times our A is 10, then minus what? Minus 1. So what do we have here? Half times 10, half times 10, then times 2 times 10, 20. 20 minus 1, we have what? We have 19. So this will now be 2 here, 1, 2 here, 5. So 5 times 19, this is 4, 5, and this is what? 95. So the correct answer is what? Is 95 meters. This is distance in the last 1 second. Last 1 second. Last 1 second. Which is distance covered in the what now? In the 10th minus 9. Are you with me? Last 1 second. 10 minus 1. Let us use this other formula to see if this will give us the same thing. If it will give us the same thing. Just to show and tell you that we know what we are drawing. Are you with me? So S10, because we have ST equals what? UT plus half AT squared, right? So let us go for S10. What will be S10? That will be U, 0 times 10 plus half. Then our A is what? 10. Then times what now? 10 squared. So what do we have there? We have here 1, here 5. That will be 5 times what now? 100. This will be equal to what now? 500 watt meter. So it means distance will be 10 seconds is 500 meter. Let us get distance to what now? 9 seconds. Okay? We now subtract. We must have the same work now. The same thing. So S9 equals to 0 times what? Times 9 plus half times 9. A is what? A is 10 times 10. Then times what? 9 what now? 9 squared. Now that will be half times 10 times what now? 81. So what happened here? Here 1. Here is what now? Is 5. So 5 times 1 will give us what now? 405. 405 what now? Meter. Are you with me? 5 times this. 5. 44. So distance in the last 1 second. Last 1 second. Because to distance in what now? 10 seconds minus distance in what now? 9 seconds. That will now be 10 seconds is what? 500 meter minus 9 is what? 405 watt meter. When you subtract, what watt now? And the 5 watt now. So that's the same thing. That's it. But understand the concept. Distance covered in the end second. We solve it in what now? Using this what now? This formula. For some more videos, okay, if you want practical physical classes, online classes for JAMB students, JUPEP students, nationwide, okay, you can join our WhatsApp group in the video below. Don't forget to subscribe. We are on a mission to have 1,000 subscribers. So please, kindly subscribe to our YouTube channel, like the video, comment on the video, are you with me, and share the links to your friends. Till we meet next time, thank you very much for watching. Bye.